Good morning, children. I am Satish, your physics teacher. Today we are going to learn about the lenses and the ray diagram for the lenses. Okay. First of all, this image is lens. What type of lens this is called? Convex lens, biconvex lens. Okay. So up to this one, convex part one side and this part second part. So biconvex lens. Okay, this is the biconvex lens. What are the namings here means at this point is called optical center O, and this point is F1 focus. Okay, and this one called to F1. Okay, F1 represent the side 1. So 2F1 is the distance from optical center to the center of this curvature. Okay. Similarly, this side will be the F2 focus 2 and 2F2. Okay, so and 2F2. These are the namings for the lenses. Okay, first we will learn the ray diagram. Basic rules for ray diagram for convex lens. So this is a convex lens. So what are the first rule is, if a ray passes parallel to the principal axis, definitely it will pass to the principal focus. This is the first rule. Okay, first rule is simple. If a ray passes parallel to the principal axis, it will definitely pass to the focus. Second rule, second rule is, if a ray passes through the focus, so if a ray passes through the focus point, it leaves parallel to the principal axis. Okay, these are the two rules. Very simple. And final rule, if a ray of light passes to the optical center, it will pass to the same path. Okay, these are the three rules. Just recap. If a ray passes parallel to the principal axis, passes through the focus. If it enters to the focus, pass parallel to the principal axis. Finally, if the ray enters into the optical center, follows the same path. Okay, these are the rules. Now we will learn the ray diagram for different positions of an object. So in this diagram, this one is object and this is then image. So this is not an image, this is an animation. So we can change the object height and distance. Okay, so we will mark the points. This is optical center O. So 0 is optical center and focus F1 and 8.2 F1. Okay, similarly this side also F2, F2 and 8 to F2. Okay, so we have the different positions where we can place this means an object. First, behind the center or infinity. Next, behind the center, at the center, in between the center and focus, at focus, between the focus and optical center. These are the different positions we can place an object. So let me learn step by step. So first position, behind the center. Okay, so this is an object. I am changing an object distance. So 8 is done. Center, so I am place an object behind the 8. Okay, so follow the rules for the ray diagram. So if the ray enters parallel, what happens? It will pass through the focus. So first rule finish. Second rule, if it enters to the optical center, follow the same path. So two rules are enough. In addition to the third rule also given here, if it enters to the focus, passes parallel to the principal axis. So wherever the rays meet at the point, you will get an image. So this is an object. So object O, and this is an image. Now we will learn about the nature and characteristics. So in this animation itself, they gave the distance. DO is nothing but object distance. D is distance, O is object. So object distance. So image distance, object height, image height. Okay. So see, object distance is 10. Okay. So image distance is 6. So if you place an object behind the center, where you get the image is between the F2 and 8 is to F2. So you get an image between F2 and 2F2. Okay. So this is the position and the nature. So whenever the image formed on the right side, definitely it would be a real image. So this is a real image, and see the arrow mark is here upward, but image is downward. So this is an inverted image. So and then magnification. What about the size of an object and the image? See, object height is 3 cm, but the image height is 2 cm. So definitely you get an image size very small compared to the object. So this is the diminished image. Diminished image. Okay. So this is the first position we learned. Okay. So next we can change an object position. Okay. So I am changing this position. Now I am placing at the 2F1. So exactly at the 8. Okay. So I placed an object exactly at the 2F1 position. So 2F1 is the radius 2F1. Okay, this point is the 2F1. I am placing an object exactly at the 2F1. Now what happens to the ray diagram? Follow the same rules. If a ray enters parallel to the principal axis, this line is a principal axis. So if a ray enters parallel to the principal axis, pass through the focus. So second rule, if a ray enters to the optical center, follow the same path. So the two rays are meet here, definitely you get the image here. Okay. So I hope you understand this one. Okay. Let we see the characteristics of image obtained when an object placed at the 2F1. So see, the distance is of an object is 8 centimeter. So and the image you get also the 8 centimeter. And one more thing, the object should be always placed at the left side. So left side you see your minus, right side always positive. So object distance and image distance you get the same. And see the height also, the object height is 3 centimeter and image height also 3. So you will get the exactly same height of an object. So what is the nature is, so whenever you get an image of the right side, this side, the image is a real and inverted. So real and inverted and same size. Okay. So this is the second question we learn. So next question, we are changing the position of an object. So here I am changing the position. So 8 is the F, 2F and 4 is the F. Now I am placing an object between the 8 and 4. Okay. Okay. So Now the position is between 2 f1 and f1. This point is 2 f1, this one is f1. Follow the same rules. If a ray enters parallel, pass to the focus, and center, optical center, same path it will move. So wherever the two rays meet, you will get an image here. Now see what are the characteristics of image formed here. First we will measure the distance. Object distance is 7.14, image distance is 9.09. So you get an image behind the 2f2. This point is 2f2 at A, but you get an image behind. So image distance is behind the 2f2. This side will be f2. So on the size, what happened to the size? See, this is an object height 2.97. Image height will be greater. So this side will be greater. So the nature is magnified image. This is a magnified image, and the image is formed at the right side. So it is a real and inverted image. Okay, so real, inverted and magnified image. Okay, so next part we will change the question. Okay, next question I'm changing. I'm going to place an object exactly at the focus point. Okay, so 4 is our focus. So I placed an object at the focus f1. So this is an object. So this case is entirely different. See what happens if the ray enter parallel, pass to the focus, and another ray through the optical center follow the straight path. These two rays won't intersect. We may consider this may intersect at a very long distance. So what happens in this case? Actually the rays won't intersect. So see here, the DO, object distance is 4, height is 2, but the image we can't actually get. If they ask nature means we may consider this two rays intersect at a very long distance. Okay, next we can change the position of an object. Now I am going to place an object between the O and F1. So I am just changing. So okay, so I placed an object between the O and F1. So same rule, if a ray enter parallel, pass to the focus and through the optical center, same path. So these two rays never intersect. For that we are make the dotted lines to join on the opposite side where the two rays meet at the point. Here you get an image. So when you get an image on this left side, this image is called virtual image, and you get the same upward, both are upward. So this is an virtual and erect or upright image. Okay, and see the size of an image. The object height is 1.19, image is 3.2. So definitely it will be a bigger one, so it should be enlarged. Okay, enlarged image. So hope everyone understand the ray diagrams for the different positions. Thank you for listening.